Okay, so for today, we're going to have week 7 for CPE 6204 or logics, circuits and system switching theory. So we're going to have our topic, design of combinational circuits 1. So here, we're going to discuss different kinds of circuits and how can they be connected with each other. So what are the learning outcomes of our topic for today? So when we say learning outcomes, these are the things that we can learn and understand upon discussion of this specific topic. So number one is to obtain the equivalent Boolean expression as well as the truth table for a given logic diagram. Number two is to construct the logic diagram, the truth table, and the equivalent Boolean expression out of a list of specifications. And lastly is to construct other and subtractor circuits. So upon discussing this today, hopefully we can understand these learning outcomes. So introduction natin of combinational circuit is there are two kinds of logic circuits in digital systems. So first is we have the combinational, wherein it is composed of logic gates whose outputs at any time are a function of the present combination of inputs, while sequential circuits is composed of logic gates and storage or memory elements. Their outputs are a function of the inputs and the stage of the storage element. So that is the difference between combinational and sequential. So when we say combinational, this is the compositions of the function of the output, while the sequential naman, they use the potential of the inputs and the state of storage. So analysis procedure when it comes to the design of combinational circuits is first to make sure that the circuit is combinational and not sequential. So yun muna yung titignan natin when it comes to analysis. Make sure nyo lang na hindi siya combinational. And number two is to label all gate outputs with arbitrary symbols. Determine the Boolean function for each gate output. Obtain the output Boolean function in terms of the input variable. So you need to take into consideration these procedures before you proceed in designing your combinational circuit. So what is the design procedure when it comes to combinational circuit? First is you need to start from the specification of the design objective. You need to first understand ano yung kailangan mo maging input and output of that specific circuit. Especially if you have a desired output, malalaman mo or matitrace back mo kung ano yung mga kakailanganin mong inputs to have that specific output. So next is to end in logic circuit diagram or a set of Boolean functions. So next, of course, ang magiging output nyo talaga dito is logic diagram na meron tayong Boolean function because that is the main reason why we design combinational circuits in order for us to receive a logic diagram. And what are the steps in designing your combinational circuit? So first, or step one is from the specifications, determine the required number of outputs and inputs. So in order for you to not be confused in designing your combinational circuit, you need to have your specification sheet, understand that there are some inputs and outputs in the circuit and kung ilan yon. Okay, so that you can design them properly and connect them properly because the more inputs and the more outputs that you have is it becomes too complex for you to understand. So make sure lang na alam mo yung specific number of outputs and inputs. Then next is derive the truth table that defines the required relationship between inputs and outputs. So we have discussed in the previous chapter and in the previous discussion how to create a truth table and how to create a Boolean expression with the truth table. So upon creating your truth table, you can now obtain the simplified Boolean function for each output as the function of the input variable. So it is important for you to understand the truth table and how it works in order for you to create a Boolean function. And lastly, upon having your Boolean expression or your Boolean function of your design, you can now draw the logic diagram. So those are the design procedures that you need to understand and you need to take into consideration before you draw your logic diagram. So hindi ka pwede na mag-drawing ng logic diagram basta-basta without understanding the truth table and Boolean function because yung dalawang yan ang mag-guide sa inyo if you have the correct input and output of your diagram. So we have here the binary adder and subtractor. So yung binary adder subtractor, by definition, it is a combinational circuit that performs addition and subtraction with binary numbers. So yung half adder natin, okay, please take into your notes here. Half adder is a combinational circuit that performs addition of 2 bits. While yung full adder natin is the it performs the addition of 3 bits. You have there the addend, the augend, and the previous carry. So that is your 3 bits. So when we say half adder, 2 bits lang yung ina-add natin while yung full adder is 3 bits. When we say binary adder, this is the production of the arithmetic sum of 2 binary numbers. It can be constructed with full adders connected in cascade. And binary subtractor, it performs subtraction of 2 unsigned binary numbers. So please take note of binary adder and binary subtractor because their difference is that the binary adder creates the arithmetic sum of 2 binary. And binary subtractor naman is yung subtraction of 2 binary. So with their words naman, no? So si adder and subtractor. So hindi nyo naman makakalimutan yung ipa-perform niya na operation. So, the binary subtractor can be also implemented so that addition and subtraction can be done with the addition of XOR gates to binary adder circuits. So here we have an example of half adder in your left and a full bit adder on your right. So when we have a half adder here, yung function x and function y natin is also an input at the same time, input din siya ng kabilang gate. So that is a half adder wherein we add uh, two binary numbers. No? So meron tayong output S and output C. While pag 4-bit adder naman, so as you can see, meron tayong apat na components dyan wherein yung output D natin, as you can see, tignan nyo na lang po yung terminals natin A, B, C, D, and S. No? So yung D natin, yung output D ni D1 is connected to dun sa C nung kabila. So that is C3. Then yung another D natin is connected to C2 and to C1. Okay, so we will have an output C and output S. No? So upon adding B3 and A3, B2, A2, B1, A1, and B0, A0. So that is how you add a 4-bit adder. No? So make sure lang yung terminals niya is properly connected with each other. So here we have a binary adder subtractor, which is an illustration of your overflow detection. Okay, so yung kanina, yung diniscuss natin, so upon making sure na yung connection natin is from D to C is okay. So pwede na natin siya lagyan ng overflow detection here as illustrated in the figure. No? So in this figure, i-make sure lang nyo lang na yung binary truth table natin is correct. Okay, so kailangan correct yung binary truth table and at the same time yung function natin ng Boolean, no? Yung Boolean expression and Boolean algebra. Okay. So ano po yung naitutulong nun nung truth table and yung Boolean algebra natin or Boolean expression? So it makes sure that your inputs and the connection of inputs are correct. No? So especially here, pag ginagawa ka kasi ng gate, no, or nagkaroon ka ng binary adder subtractor, most of the time, if mali ang connection mo, mali na rin yung output mo kahit sa umpisa ka magkamali. No? So, Boolean expression and truth table helps you be guided what are the supposed to be output of your diagram. Okay? So that is an example of binary adder and subtractor. Okay, so that is the end of our discussion for design of combinational circuits 1. So